I thought as a kind of fun way to get us started today, I'd just take you back to a conversation I had with my son about a week and a half ago. So we were on a little family trip, and I come into the hotel room. We're up in northern Wisconsin, and he's watching videos on my laptop. And what he's watching is this one right here, all these buildings collapsing. I'm like, what do you think? He's like, this is awesome. Do they do this all the time? And I said, well, yeah, whenever they get old, they got to knock them down like this. And he's like, how do they do it? And I'm like, well, you can hear it. It's not on mine, but it's explosives. And he's like, this is amazing. And I said, yeah, but there's a much better way to do this. And he's looking at me like how? And like, when are we going to do it, Dad? And I said, no, we're not going to do this. But I'm telling you, there's a much better way to, basically knock down old buildings. And he says, how? I said, just suck the air out of them. And he's like, what are you talking about? I said, no, if you just put a big wrapping over the building and suck the air out of it, the atmosphere can crush it way more efficiently than that. And he looks at me and says, Dad, the atmosphere doesn't weigh anything. And I look at him and I said, what do you mean it doesn't weigh anything? Look, he holds up his hands like, I can't feel it. And I said, oh, this is a good learning moment. So I thought I would just tell you what I told him and have a little fun with this. So I told him to wrap the building in plastic and suck the air out of it and let the atmosphere crush it. By the way, if we did that to the I Hotel, that's 500 million pounds of force that would crush this building. And by the way, it would hold all the dust in, would make such a massive mess like you see here. The atmosphere is extremely heavy, and the fact that you can't feel it does not mean that it doesn't have mass. And this is what I taught my son. I think it'd be kind of fun to teach it to you today. I call it the poorly designed experiment. Now, before I go a moment farther in my talk today, because we're going to get to all those really important topics about South America, about what we think might happen this spring, and the bigger picture on how weather is impacting production agriculture. I'm going to tell you something, and Matt said the same thing at the beginning of his talk. Stuff changes constantly. You all know this extremely well. But like Matt, I try to stay on top of it every single day. And right down here at the bottom on this first slide, and you'll get this when Amy sends out the presentation, that web address you see here at the bottom, you can sign up for my free daily reports. When Nutrien hired me, and I've told some of this before, I said, let's give folks weather content and give it to them in a timely fashion that they can make decisions off of. And I said, this is going to be one of the best ways to do it. And through that, all you just put your email in it. And here's the good news. When you put your email into that web address, all you're going to get added to is my daily list. That's it. We're not putting you on anything else. You're not going to get spammed other than from me with weather content. And by the way, you can delete it. I don't care. If you're like, I don't care to delete it, because I'm going to do another one tomorrow morning, and you can read that one, all right? Just don't delete them 16 times in a row. Because we set up a little algorithm that says if you delete it 16 times in a row, that must mean you don't want it. And we're just going to unenroll you. That's all. So we just don't keep bothering you. But as we go through this, I want to come back to this poorly designed experiment idea. So this is what I told my son. I hope you get a kick out of this. So this guy right here, kind of famous in science circles, his name is Aristotle. He wrote a book, this was about 340 BC, where he was doing a lot of these experiments designed to understand the atmosphere and how it behaved. And in one of his experiments, in his book called Meteorologica, he wanted to answer the same question that my son proposed, which was, does the air weigh anything? Does it have mass? Now, he set up an experiment that he thought would help prove the answer to this question, does it have mass? And this is what he did. Took a wineskin, like the one you see over there on the left, got the best set of scales that were available to him, put the wineskin on the scales, balanced his mass out so it was just, perfect. And then what he did was he took the wineskin off, filled it full of air, sealed it back up, and put it back on the scales. And what happened is it balanced with the same amount of mass. And from that one experiment, for literally centuries following that, it was understood that the air was a weightless property of the atmosphere. And what I'm telling you is this is a terrible way to figure out if the atmosphere has mass. We know it has mass. You can feel it when the wind blows. Newton came along several centuries later and told us that a force is a mass times an acceleration, which means if you can feel something pushing against you, it's got to have mass to it. Now, why was the experiment bad? Let me just give you the answer today. When he put that wineskin on there empty, the air that he eventually blew into it was already being measured the first time around. He just put it on the inside rather than the outside. And the reason why you can't feel it or why you don't think that this building is holding up the air above us is because air pressure is a three-dimensional thing. So if I hold my hand out, I'm not weighing the 15 pounds of force that's from here to the top of the atmosphere, because it's not only pushing down, it's pushing on the sides and pushing up. And therefore, you never feel it. But when it changes, you get everything else I'm going to talk to you about today. And it's changes in pressure. In fact, I had a little discussion with my son. He's still not quite sure what I do for a living. When I tell him, like, well, people for some reason want to hear what I have to say about the weather. He's like, really? And I'm like, yeah, I'm going to go tell more of them about it today. We had a discussion this morning. He goes, what are you going to tell them? I said, basically, son, I'm going to tell them that I'm chasing the wind all day long. I want to know where it's going to go, where it's going to gather, what it's going to push along its way. You know, this was just a great video. It came out a couple of years ago from Texas. These are not migrating buffalo. Those are migrating tumbleweed, right? I mean, this is evidence that the atmosphere is moving. And as it moves, it means in some places the air is going to gather. And where it gathers, it's got one option. It's got to go up. And where it spreads apart, it's got to go down. So a more refined definition of what I do every day is I am someone who's forever looking for where the air goes up and when the air goes down. Because for the last several weeks, here across the midsection of the United States, the air's been going up, and it's been going up violently. December the 10th, massive severe weather outbreak in Jeff's part of the world. December the 15th, in the western part of the Corn Belt, nearly 1,000 reports of severe storms ripping through that area. That all happens when the air ascends in a violent manner, just like this. The only way that it gets up is something's got to trigger it to go up. And the way you do that is you simply change the pressure. And what I just teach you, change in pressure is a change in mass. We're just constantly looking through this invisible gas to see where it's gathering and where it's spreading apart. Over those same weeks in South America, we've been practicing avoidance of where the atmosphere is gathering, and instead we're getting subsidence and it's sinking and it's getting very, very dry in southern Brazil and Argentina. They're going to get a bit of a switch of that. And I'm going to tell you that the very last thing today, because I want that to be on the front of your plate going forward with your thought process on markets. Because if there is a weather marker right now, it is in South America. But we will be covering what got us there. We'll talk about what this winter and spring are likely going to hold for us so that we can at least see where we're going in the future. And as always, things that I'm going to talk to you about today, they're going to change. And that's why I want to give you the free daily stuff so that you have access to all of it, all right? So that's where we're going today. Now, when the wind really starts getting to go, we produce massive hurricanes. And this was an interesting year this past year. Each one of those squiggly lines is one of the different paths of one of our tropical storms this year. And these big tropical cyclones thankfully avoided running up the gut of the Mississippi River and dumping a bunch of precipitation on us. But I do know that I work for a large ag company that sells inputs that you all buy, and I understand, I know very well what the prices are right now. But I'm going to tell you something. Mother Nature did not help with this scenario. This was the biggest, Ida. That's Hurricane Ida strengthening to Category 4 strength. Those wind speeds really cranked there. At one point, we're gusting over 160 miles an hour, okay? Now, as Ida was making its way toward Louisiana, if you've never been down to the Gulf Coast, you get just offshore, and it is lined with basically places that were pulling fossil fuels out of the ocean bed. And there's a bunch of refineries and places where we process that into all sorts of different things. And of course, one of the things that comes out of that is the production of nitrogen. Well, that massive hurricane going toward Louisiana, and don't forget, Louisiana was hit 5 times last year. Well, as this one came on shore here, it pushed a bunch of water out ahead of it. We call that storm surge. Got to be about 10 feet deep in and around the New Orleans area. When the winds came in with it, this is what they looked like. For about 7 or 8 hours, we had wind speeds that were gusting at times to 85 miles an hour in downtown parts of New Orleans here. And you can just see it coming off some of the larger buildings there. But if you saw me present this in the fall, I got to show you one more thing again, and that's this graphic right here. Now, what you're looking at in that red line on top is the normal discharge rate of the Mississippi River. About 350,000 cubic feet per second leaves that river. But when Hurricane Ida came in and the right-hand side of the hurricane was pushing against the river, it stopped it. There was a little while there. See the dip that's right over here? That little dip there was when the river discharge rate went negative, which meant those strong winds took that Mississippi River, which drains 40% of the United States land area, and stopped it for a while. The water built up about 10 feet, and then the hurricane moved on, and all that water went out. We got a little bit more added to Louisiana as that occurred. Amazing what happens when you start to change the pressure around. In the month of December, we added 3 new billion-dollar weather disasters to the 2021 total, which is now at 20 separate billion-dollar disasters. And this was one of them. The way the pressure changes coming off the mountains can often produce what we call downslope wind events. The winds come over the mountain, they descend compressionally warm and get really dry. The humidity levels here were measured at 5% back on December 30th. when that wind coming off the mountain, called a föhn wind, hit those power lines, starting a fire. And that fire then blew across here, moving at a rate of 0.2 acres a second. So if you want to know what that's like, it's from me to the back of the room in a second. That's how fast that fire was moving. But those winds were gusting at 115 miles an hour, carrying that fire with it, and easily topping $1 billion in disaster. Now, I get asked this at every single conference I present, so let's discuss it. This came up when I was back in Great Falls, Montana, back in December. This woman sent me this picture after she met me there and says, "You're never going to believe what was in our newspaper in Idaho." So here we are. Enough with the wind already. Ever since they installed those big fans up on the hill, it's become windier. Whose bright idea was that? I noticed when they turn them off, it's a nice calm spell. Please turn them off, at least on the weekends. Now, I don't know if Jeff here is just joking around or if this was a real op-ed where he was quite confused, but I think we should just take a moment and talk about wind turbines, because we've got them everywhere. All I'm going to present to you in the next 2 minutes here is what the current level of scientific understanding is about them from peer-reviewed research. And we're going to start with whether or not they are impacting precipitation. So there's a paper that's going to be coming out very soon. It is not out yet. This is the preprint edition that I got a chance to read. Back in June 18th, 2019, we all, meaning us meteorologists, witnessed a very interesting event in Texas. And that's just the screen grab here of the particular figure that it's of interest. I'd like to actually show you the real radar data, because I saved it off that day too, because we all saw something we didn't know could happen like this. So take a look at this. Ready? This animation right here is from the Lubbock, Texas radar. So that little black dot is where the radar is located. As the animation goes forward, you see a big squall line of thunderstorms coming out of the north and west. And it goes right over and just north of Lubbock. Now what I want you to see as this resets is this right here, all those bright radar reflectivity echoes. I'll circle it again, there it is. Those are all the wind turbines. So the turbines are so tall that the blade will actually come up and will hit it with the radar beam when it's at its peak. It's a big object, so we get a bright reflectivity from it, and that's why it shows up in those colors. Now you probably already see what I'm talking about here. You notice when the storm is moving forward, you see that pencil-thin line of lower reflectivity values that just arcs its way out ahead of the storms? That's the outflow of the storms. You've all felt this. Big storms come over us here in Illinois in the middle of summer. The winds shift direction, it gets cool briefly, and then the storm follows it. That's the thunderstorm just exhausting. It's breathing out its air, and it leaves the front edge of the storm and just usually sits out ahead of it. You get a big shelf cloud on that. You've probably seen those before. Well, if you take a close look at the behavior of that outflow boundary, do you see that when it hits the wind turbine field, it goes from being nice, looking like a big arc, to having a big dent in it? We measured that that particular storm was slowed significantly by the wind field. It's a big one, a big wind turbine field here. But that began this new bit of research trying to understand, are storm systems, precipitation patterns, are they changing because of us putting big fans in the atmosphere? And we're beginning the research. I know nothing more than what I just told you, and nobody else does either. Are we clear on that? We got to study this. So please, at the end of the talk, don't ask me what the local wind farm is doing to your area, because I don't know. None of us know. It takes a long time to build up enough evidence, enough statistical evidence to give you a solid answer. What I can tell you, though, because this research was done in the state of Illinois, is that these wind turbines are very effective at mixing out the lower levels of the atmosphere. Now, what I'm talking about with respect to that is that you know that most nights when the sun sets, you get a good inversion, temperature inversion. It's cold at the surface and warm aloft. The wind turbines, as they continue to move in those stronger winds aloft, will mix the warmer air down from above to the surface. So we have found that downwind of wind farms, this is peer-reviewed publication, not my research, someone else's, that showed that the overnight low temperatures had increased on the prevalent downwind side of wind farms. So it's mixing out inversions. And that's really important for what we do. And if you need to make sure you know what these inversions are, I'm going to remind you very importantly how they work. If it's the middle of the afternoon and it's June, we know that's typically hottest at the surface and gets colder as you go up, right? That's a typical day. Because of that, because it's warm at the surface and cold aloft, we can get a couple of things that'll typically happen. The first thing that happens is often we get much stronger winds from aloft to mix down. You ever notice that? Middle of summer, it's windiest in the afternoon. That's because if the temperature cools dramatically with height, The atmosphere doesn't have to work against itself to bring those stronger winds down. Now, it's funny, this past year I was down at camping with a bunch of buddies and our sons down just south of town here. It was a really windy Saturday, and we're sitting around the campfire, and it was a little chilly, and I just made a comment, like, yeah, as soon as that sun sets, these winds are going to calm down. And this one guy from Florida who did not know what I did decided to give me his explanation for why that wasn't going to happen. The other 4 dads knew what I did for a living and decided to not talk, which meant it was a fantastic evening because he claimed that the reason why it was doing this, actually I don't remember, but it had something to do with the phase of the moon, and that's not how winds work. But anyways, he keeps going on and on and on, that sun sets, and all of a sudden the winds just calm down. And the next morning after I left, all my buddies told him that. He's a professional meteorologist that you just argued with, and I haven't heard from him since. But when the winds change like this, what's important to understand is that during the day you can get that to happen. The atmosphere doesn't like this either. It wants to overturn itself. And the overturning takes all the warmth at the surface and gets it to rise quickly. And that's how we build these massive thunderstorms like the one you see over here. Okay, as soon as the sun sets, all that goes away. Those big rising thermals, they shut off. And you develop an inversion. Can you see it there? Here's the top of it right there. Those strong winds want to mix down, they can't do it. They hit that inversion. The density, therefore the pressure of the atmosphere changes, and they can't push through it. So the winds calm at night. But as that inversion there, the warming of the temperatures with height at the surface, right? See that? As the night wears on, that inversion gets deeper and deeper until you have sunrise. And the moment the sun rises, you can see the inversion because inside of it, as the temperatures cool off, often you get down to the dew point. And it makes clouds like you see right here. Well, we call that fog. Now, the moment the sun rises, the lowest level of the atmosphere starts to warm up again. And that layer of fog lifts. We often call it lifting, but really it's just eroding from the bottom. And it looks something a bit like that. And this makes it tricky because in those early morning hours, you still get the turbulent mixing below, but you have the inversion sitting on top. Now, I get asked, well, how often does this happen? Every day, unless it's windy at night. There's an inversion every single day. From 9 p.m. to 9 a.m. in summer, you're going to have one every single day unless it's windy at night. And that mixes all this out anyway. So we're watching for stuff like this every day, but I just thought I'd give you just a 2-minute lesson here on how these things work. That's how the inversion changes every single day of the year. So we got to measure it. And this is one of the ways by which we do it. We have weather stations all over the United States, National Weather Service weather stations, where we go outside and try to launch balloons. Now, thankfully, they're pretty sturdy instruments. In fact, how many of you found one of these in your fields? Okay, mail those back to us. Show the kids and then put it in the mail because we can reuse them. Helps our budget a little bit here. If you disked it, then keep it. I don't want you to put it in the mail. But those things, we have a goal with these, and this is where we get into the meat of what we're going to talk about today. I want to get that balloon to 90,000 feet. That balloon is pretty small right here. It's about 4.5 feet across when we fill it up. When it gets to 90,000 feet where the pressure is extremely low, it would go all the way to the top of the ceiling. In fact, it would fill most of this space right in through here. It expands. That's how big those balloons are. We've blown them up that big on the surface to see how big they get. But anyways, they get them up in the atmosphere to see that. Okay, what is this? The jet stream. I told my son I'm looking for where air goes up and down. That thing right there tells me where it's going to do it. I watch the flow of the winds that are always hurricane force 6 miles above our heads constantly for their changes in position. Now, I cannot tell you whether or not next summer is going to be a drought summer or it's going to be like a bin-busting kind of yield summer. Nobody knows that yet. If they tell you they know it and they get it right, I've told this group before this, right? That was an accident, happy accident. But the reality is we can't predict it. You know the proof in this? I'll give you 2 cases of proof today, one now, one later. First proof is market rallies on bad weather typically start in June, don't they? Because that's the first time we actually get an idea about what the end of June and early July is going to actually be like. Everything before that is speculative because we're looking at these little ingredients coming together to tell us if something's going to happen. And I'm going to tell you what we're going to watch so that when we start talking about it, you know what we're going into. So here you go. This is your lesson today. This is right here off the National Weather Service website. Beautiful graphics to explain to you my job every summer. Just like you felt after Thanksgiving a little blocked up, remember that? The atmosphere hates it as much as you do. It wants everything flowing smoothly. And a smooth flowing atmosphere just meanders a little bit north and south, but it goes from the west to the east. Whenever it moves more north-south than west-east, the atmosphere is blocked up and the blocking patterns stay put, they get stuck, sometimes even go the wrong direction. And depending on where you are with respect to it, you either get too much rain or not enough. And I want to show you the 3 types of blocks that we worry most about. On the left is called the omega block. Looks like the Greek letter omega. Do you see that? In the middle, that's 2012 in a nutshell. Big blocking high pressure center where the jet stream went all the way into Canada and never came back. Over there on the right, well, that particular block you see over there called a Rex block. It gets its name from the guy who figured it out. His name was Rex, is when you have what's also called a high over low. These are very common along the West Coast. I'm going to show you what each of them means to us by giving you some hard evidence on exactly how each summer plays out to either give you massive yields or have problems with those yields. So let's get into this. I've been studying this since 1980, not me personally, but I looked back at the data over that time period. And I'm going to show you this figure again. I showed it to you last time we talked. It's yield variance. Who are the places or where are the places that have the most susceptibility to those blocking patterns? And when you look at this particular map, those blue colors are the lowest variance locations. What that means is in those locations, year-on-year yield bounces around a very, very small trend line. And that's usually because they irrigate those acres. Look at Nebraska as an example. In those middle colors, the yellows to the whites, that's where you have your normal yield variance across the country. It's the I states. We have the best soil. We typically get about 40 inches of rain. We typically don't endure extreme heat in the summer, and you put all that together and things look pretty darn good. You go north of that into the northwestern part of the Corn Belt, the Dakotas, there's prevent plant issues, one. Second thing we have up there is that they can really get dry fast in the middle of summer, causing big yield issues in summer. And on top of that, they can often have early frost that'll ding their yield as well. The south and southeast, I think you know what's going on down there in terms of controlling this. But this is what I want to share with you about it. Matt brought up earlier what happened in 2012. In 2012, we saw kind of the most feared temperature patterns that give us terrible yields. And I want to just show it to you. I call it the M's and the inverted V's, so you can remember this really easily. That map that's over there, that graphic on the left shows you the daily high and low temperature for Champaign. That's in those blue bars every day of all of 2012. And what I want you to notice out of this is how the temperature pattern looked right around pollination. We had multiple days of greater than 97 degrees Fahrenheit, which is what the research says is where corn really starts to show signs of stress. Now, how did we get there? What is it that we are forecasting that can cause those kind of problems? Look at the map that's on the right. That is what the jet stream did in summer, but let me annotate it for you. Those reds are where we have big ridges. And the flow around it did something like that. And that big ridge that you see right there sitting over the Dakotas, always just downstream of it is where you get high pressure. We do not want high pressure at all during summer. Keep that away. Because high pressure sitting over the Midwest, the flow goes clockwise around them just like this. And if you see this, right, see those arrows? You don't want your winds coming from Wisconsin in the middle of summer. You want them coming from the Gulf of Mexico. That's our moisture transport. Because of that, the skies were clear, the temperatures were high. We did not get precipitation. Why? Because the jet stream avoids high pressure, goes around it. And it kept feeding back on itself, leading us to one of our worst yielding years in the state's history. Now, on the flip side of that, y'all remember 2014? That's the M. Ready? See the temperature profile over here? I'll label it for you. See how it looks like an M like that? Right in pollination, the jet stream went into a pattern like this, where the ridge was west. Everybody in this room wants a western United States ridge every summer. I hate to say it, and I've told you all this before, but every year that you hear stories about the West burning are great years for us. And that's because the jet stream's got to go around that big ridge west and dip into a trough over us. And those troughs bring in unsettled weather. They bring in the precipitation routinely. And what we end up getting is some cooler weather, and our crops tend to do fantastic. Now, what was 2021? I call it the cursive M. Do you see it? It kind of did something like that. I remember we started writing cursive M's. They got 3 humps to them. It looked like this. But notice we never saw these temperatures getting anywhere close to that 100-degree mark. And that's because the West took the ridge again last year. and the flow had to go around it. Now, at the surface, you don't want winds out of Wisconsin, but aloft, you do. Because winds that come out of Wisconsin from the north in summer blow up big storms for us. We love northwest jet stream flow in the middle of summer, and we had it this past year. That big high pressure cell sat right over the Four Corner states, and as a result of that, we saw this. That's the jet stream at the end of June. That ridge you see spinning there over the Pacific Northwest and British Columbia was the farthest to the north I'd ever seen the jet stream go, and I've been watching it for 25 years. It's amazing to see what was going on there. Where were you? You were down here on the downstream side, and right where I am today, I was back at the end of June, and we had just gone through about 7 days where we got like 1.5 inches of rain every single day. 10 inches fell in this particular area very, very quickly. Not in the west. Portland, Oregon hit 116 degrees Fahrenheit on this day. Smashed all of their records for the entire state. That's what the summer looked like. This goes from June 1st all the way to August 15. Every single climate reporting district on this map has a number. The closer you are to 1, the warmest. The closer you are to 129, that would have been the coolest. You can see where we sit, right about average. All the heat was taken in the west. I've been measuring it with some new tools that I'm producing that you can all have access to. I pulled this data right here from Champaign, and what I want to show you is you got your accumulation of GDUs going forward on this graph. There's 2021, just put a thick black line over the top of it. Because all that heat was in the west, you compare the rate at which we accumulated heat this year to previous years. I got them listed right up here, and it was lower. But we had a really long growing season this year. Last frost right around here was April 22nd. First frost was November the 1st. See those blue lines going up on the graph? Those are the times in the past where we've had frost events over the last 40 years. So we were a little late with a late frost, April 22nd. And then we were way late with our first frost at the end of the year. That whole setup is what gave us a really long time period to get this crop and get it looking good. There was one thing that disrupted it, though, and it's seen here on this precipitation graph. So now we're looking at the whole year, last year, at precipitation as it was accumulating. We finally got into the fields in May. We were a little bit too wet at the end of April, but in May, good dry stretch there through most of June. Then all of a sudden in June, it got really, really wet around here. Most of us had our crop in, of course, by that point, but it just poured the rain. But right here was where the money was made. See that nice stair step to the view here on the precipitation? The more that looks like a set of stairs, the better your crop is going to look. That's routine and regular rainfall. We got plagued, though, right here in October. Big rainfall events in October that chased a lot of us out of the fields. But we finished the year in Champaign County at 109% on average on precipitation. Had this event right here not happened, this really, really wet weather, I think we could even seen those numbers go higher. It certainly slowed us down in terms of harvest progress. That's in a nutshell what we experienced right here in Champaign County. And as a result of that, this summer for our climate reporting district was the 7th wettest in the last 129 years. Look how dry it was just on this side of the Mississippi River, then into the northwest. Extremely dry there. Remember me showing you that big high pressure cell? The west burned underneath that. This is what it looked like on satellite back at the end of July. Now, I'm sure a lot of you remember at the end of July, looking to the west when the sun would set, and it was just brilliantly red sunsets. Remember that? You probably also remember the sun setting several degrees above the horizon. That was because it was setting behind all the smoke from these fires. And I've been showing this since fall, but this particular fire right here, this one in Oregon, was just terrible. Sent smoke all the way to Manitoba, made a hard turn to the south, came right over the state of Illinois. We've been doing some research about this, looking at these massive wildfires. This is one in California this past year. These big wildfires, we track how much smoke they put in the atmosphere. And I brought along with me an animation from the end of July showing you the smoke extent from those western wildfires. And this is what we figured out for the state of Illinois. No, I do not know what the impact was on yield, but I know what it was on certain atmospheric variables to have that much smoke in the upper atmosphere. We measured, on average, a 2 to 7 degree Fahrenheit decrease in maximum temperatures because of the smoke. Basically, the smoke was acting like a bit of a shield, preventing on clearer days the intense sun getting all the way to the surface. 2 to 7 degrees cooler than if that smoke would have not been here. We also measured a 15, that's 1.5, a 15% reduction in direct sunlight. Smoke gives you indirect sunlight, not direct. There's been some estimates that that had an impact on soybean yields. I do not know because with the soybeans, we still had all the moisture. We were getting the indirect light, but some folks were talking about a loss of about 3 bushel on soybeans. I don't know, though, how we can single out that one variable. Our friends to the north are having problems as well. Just gave a talk yesterday to a group in Canada, And if you look at this graphic, it shows you since 1950 what the summertime precipitations look like for our friends up north. That trend line in the middle shows that they've increased total precip across the Canadian Prairie about 1 inch since 1950. But this past year, right there, it was the driest it had been in the Canadian Prairie going all the way back to 1979, and before that, 1967. And the way that the drought expanded across the Canadian Prairie this year was just widespread, and it hit everyone really hard. Now, I'm going to show you 2 maps for it real quick. It's this one's first, but this is the one I want to get to. What I did was I turned white everywhere on this map that saw more than 120 millimeters of rain, about 5 inches. All of the area that you now see color on this map shows you where they saw less than that. And there's major problems in Alberta, which is here, and Saskatchewan, which is there. This huge growing area right in through here did not have enough moisture to wash away the residual effect of some of the applications. And that means they're going to change those acres away from what they had grown last year to something different. It's a lot of wheat and barley and canola and things like that. But we're going to watch this area very carefully. So I just want you to know, to our west and to our northwest, terrible, terrible year this year. So we asked these questions, and I'm going to get into a bit of a long-term discussion here with you. Is there any sort of evidence that these things are becoming more persistent? We should be asking that because we want to know, for this state, how are things changing? For the West, how are things changing? Because I told you a few moments ago, you always want to watch to the West to see what their summer setup's like, because it could impact us here very, very easily. And here's the answer to that. This particular figure from the journal Nature, peer-reviewed journal here, don't forget, shows us that over the last 70 years, see that top figure where the red is? That the Western United States has experienced more frequent ridging. And if they have more frequent ridging, we're on the downstream side of it, we have more frequent troughing events. That right there is what happens when you let someone that studies this tell you what climate change is actually about. There's no political rhetoric here. The West is getting hotter and drier, and at the expense of that, downstream around the Great Lakes, we are getting the opposite. And I want to prove that to you and show that to you. National Weather Service just updated their climate normals this year. We do that at the beginning of every new decade. And the new climate normals show when you get rid of the old data set and add the new, which means we got rid of the 80s and added the 20-teens, that we can look to see what the annual temperature change is like. And most places across the United States saw about a 0.5 degree to 1 degree increase when we added the new decade on. But look more over here on the right. You can see that if you get to the east of the Continental Divide, which is about right there, more places here saw an increase in total precipitation throughout the year than saw a decrease. I'm going to give you some numbers to put on that in a second. Whereas west of the Continental Divide, it got substantially drier. That's the long-term shift in those climate normals, which show us how the change is actually behaving. So we ask these questions. First, what are the frequency then of big events like 2012? That's my hand there holding that ear of corn. That came from a good friend of mine, Jerry Cassida. If any of you know him, he used to farm down there in Tuscola. We did a scout in August, and I pulled that out and said, "Can I keep this?" He's like, "Yeah, I don't have any use for it," because this is how terrible it was in 2012. You look historically going back, there's only been a few years we've gotten that bad. 83, 88, and 2012 are the years that stand out. But this trend is real. And we want to know, does that trend keep going in that direction with time? So I want to show you what we know about Illinois. All right, so listen carefully to these numbers. When we look at our spring time period, April through May, since I was born, 1980, there you go, we have actually seen an increase overall, see it right here, in total precipitation in spring. That's what that trend line shows us there. It's about 1.5 inches. Now that increase in spring rainfall is actually coming at in interesting ways. We're actually getting more of that rainfall from bigger events where we get more than 1 inch of rain in a day. Because of the increased total number of precipitation events and the increase in the frequency of the heavy rainfall events, we did a study on this and found that we lost about 5 days in April and May, 5 days total in April and May, where we could get out in the field and do work. That hasn't had an impact because during that same 40-year time period, you bought bigger and better equipment. But that's the number, a loss of 5 days. We talk about precipitable water and humidity. What the heck is precipitable water? It's how juicy the atmosphere is. How much moisture is there to be precipitated out? We have measured that since 1970, we've increased that by 15%, which basically means the atmosphere is just juiced and ready to make precipitation, and those numbers are increasing. It's being helped along by warmer overnight low temperatures, which is a reflection of the dew point staying a bit higher. Total relative humidity has increased about 6%. Relative humidity, by the way, is a useless term. I wish we would just get rid of it because it's relative to the temperature, so don't use it. The relative humidity outside right now is high, but it's dry because it's so cold. I'll get into that some other time. But let's get into this. What about our whole growing season? Now, you're looking at the primary corn and soybean belt, which goes from North Dakota down to Kansas and all the way over to Ohio, okay? But when I'm looking at this, these are the same numbers that we have for Illinois. April to October precipitation since 1950 is up 5.5 inches. That's our long-term trend. And when you look at this, the only issue I have with it is that we're increasing the frequency of our big rainfall events. I brought along Iowa along for this discussion as well. Iowa's tripled the number of events they have every year where they get more than 2 inches of rainfall in a day. Illinois, we've doubled that number. So it means we're getting wetter, but we're getting wetter in big helpings. We talked about 2019. Matt talked about it a little bit. You remember what happened in 2019? Rain like mad until June. Did it rain in July? No. This is what the atmosphere and the shifts are doing. And I want you to remember that we're keeping track of this and providing you with some statistics. Because of that, and Jeff and I were talking about this beforehand, we're seeing a bit of a shift in our severe weather, and you want to pay attention closely to this. Earlier I was talking about the outflow of thunderstorms. That's what often forms on them. It's called the shelf cloud. That cloud is your warning cloud. I think I've told you guys this before. When you see that, you get out your phone and take a picture of it. You email it to eric.snodgrass@nutrien.com, and then remind yourself that you've got 5 minutes to get inside, because what's coming behind that's going to try to kill you. I mean, literally it will. It's a powerful, powerful storm system. They're notorious for their wind damage. Every year, just in reports, we have around 15,000 reports of these things. And this particular year, we got way up there with those reports as well. We hit right up here 13,349 reports of severe winds. And these ripped through us in August this year. We had some pretty nasty winds in August. But we also had them in December. On December the 15th, this whole area here was under some form of high wind warning. So it's not just during our growing season. And as those winds came ripping through, they came out of the south here first before they shifted around. Those south winds brought Gulf moisture, which fed a massive line of storms that produced winds themselves, which we were forecasting to be somewhere in the 60 to 90 mile an hour range right in through here. By the way, that's not the thunderstorm winds. That's the speed of the thunderstorms. Then the thunderstorms themselves were producing their own outflow. On the back side of it, and you better remember this, okay? The southern plains are so dry right now, and this is key for next season, that we produced a massive dust storm out of it. Do you see the dust getting pulled through parts of Kansas and Nebraska here? Watch it over again. It'll play again here. And I was also reminded of the Ken Burns series on the Dust Bowl. Like, this is what we saw. This is going on right now in the southern plains of the United States. It's very dry there. You look at those soil moisture values at the end of December, there's a huge area here that has continued to get drier and drier and drier. Soil moisture values in this area down to the 2% range. We're helping these out lately. We've really made a major improvement over in the east, but it's been a pretty rough go. And then before that, this was the system, no, this is actually the system on radar, just to show you that squall line, moving at about 90 miles an hour at times here. As it went across, it produced 657 reports of severe weather. In December, incredible to see that. What about hail? I know we talked about hail earlier today. It was in the crop insurance part of the meeting. 2021 was weird with hail. We had less than half the normal number of reports. In this particular year, we did get some hail in the west, and I map it every day. If you'd like to see these maps, and if you've got a scout, I'll provide this stuff to you free of charge. But I remember some nasty storms that came into western Illinois here back at the beginning of July, and this one right here in Iowa. I brought a picture from that one in Iowa. So if you need a reminder, even though this year was down on hail, of why you need to get that coverage, it can just come through and rip through a field like this. Quick lesson about hail. If you have a good radar app, I would recommend one called Radar Scope. That's the one you're seeing here. It's the best radar app in existence. We make a very distinct break in the color bar right here from the reds over to the pinks and purple. We do that because when we see very high radar reflectivity above a value of 60, usually that indicates that the radar is scanning through hail. So as you watch this storm north of Dallas-Fort Worth, which was this year, Do you see right in the middle there's a pink and purple blotch? That is where the radar beam is scanning through the big hailstones. They were baseball size in this case, and they caused over $1.5 billion in damage to parts of Dallas-Fort Worth area. They'll spend, like we did, 3 years cleaning up after this. Is anybody still waiting on to get their roof repaired from stuff we had last year? I know the church I go to still has yet to have theirs repaired, and we got in a bid a long time ago. This is just how long these disasters take to clean up. Tornadoes, we were at 90% of normal until the December 10th and December 15th event. And that December event shifted our attention away from parts of the south, which were hammered earlier in the year with tornadoes. This was down here in Mississippi earlier in the year, on May 2nd, big outbreak down there, and pulled our attention back to the north. This particular system was back on December 10th, ripped through Illinois, hit southern Illinois hard, but really hit Tennessee and Kentucky the hardest. And you know what I'm talking about? It's that Mayfield tornado. When it was all said and done, 404 reports of severe storms, and we thought we broke a record which was set in Illinois in 1929 by the March 25th, 1929 tri-state tornado. There was a supercell that started in Arkansas, cut across Missouri, Tennessee, and finished almost near Louisville, Kentucky. And along its way, it produced one tornado that was on the ground 163.5 miles. It was a wedge tornado, one that is wider than it is taller. And it was eventually rated as an EF4 tornado, producing 190-mile-an-hour winds. But we were measuring this thing with radar. Let's get to the radar imagery here. And as that supercell just went right south of the Paducah, Kentucky radar, that's this one right here, we saw a really well-defined hook echo. But these pinks and purples right in here are not hail. That's debris. That's stuff the tornado picked up and tossed. Because we were able to measure with radar that gate-to-gate velocities of that tornado. That means these blue to those deep red meant we saw crosswinds that added up hit 300 miles an hour. So remember, when we rank tornadoes using the enhanced Vegeta scale, the tornado has to hit something to know how to rank it. And what we found evidence of was 190-mile-an-hour winds from the stuff it destroyed. If a big EF5 ranked tornado with maybe 300-mile-an-hour winds went over a plowed cornfield, you can't rank the damage from that. We don't know how strong it was, but we measured here on radar what it looked like. This column you see right here shows us that debris from Mayfield was thrown 30,000 feet into the sky and transported from Mayfield all the way to Louisville. They were finding stuff from Mayfield in Louisville, Kentucky. Incredible to see the power of these storms. Well, what about change with these storms? Well, let me tell you something. During La Nina winters, which we're in, and that's going to be a major part as I finish up today, during La Nina winters, we tend to have more frequent mid-south tornado outbreaks right down here. We've been researching this for 70 years, and that's the case. But here's the more important figure for all of you. You think about buying that multi-peril product, I'm just going to show you this. Northern Illinois University, a good friend of mine named Victor Cassini, did some groundbreaking research where he studied from 1979 to 2020 what the changes have been in the prevalence of the ingredients that come together to make tornadic thunderstorms. You see, you can't study historical tornado reports because over that time period, the number of people that live in that area that could report them has changed. The reporting standards that the National Weather Service uses has changed, which means the statistics don't make sense when the way people report them changed over 42 years. So we've shifted this, and instead, we've been measuring the ingredients for a while. And what you need to remember from me today is Tornado Alley is shifting east. Do you see that? We are now in the state of Illinois seeing more frequent events where the ingredients that have to come together, primarily wind shear, are coming together over this part of Tornado Alley and moving west to east. So our run-ins with severe weather are increasing with time. Those are the same thunderstorms that deliver the life-saving rain for our crops, but sometimes they do so a little too violently. And I want you all to know the importance of that kind of coverage, given that your local meteorologist just told you that the ingredients coming together to make all this are increasing. So now we get to the stuff that I put at the end so that you wouldn't forget. I want to make sure this sticks in your brains. Tomorrow morning, I'll get a new update from the Drought Monitor. It comes out once a week from the University of Nebraska at Lincoln. And the latest Drought Monitor still shows extensive drought across the United States. There's one area that you need to watch from now all the way through the end of May, and it's the Southern Plains. Oklahoma, Kansas, parts of Colorado, New Mexico, Texas. Watch that area carefully, because over the previous 3 months, that part of the central part of the United States has seen up to a 4-class degradation in drought. And if that drought is still there by the time you're in the fields in spring, and I'm not talking about it going away in May or June, what we've found is that when you get into summer, it expands. The drought we experienced in 2012 began as a Texas drought in 2011. Do you remember that? Every year we watched that very carefully. Now last year it was corrected and cleaned up by the time we got to June. And that prevented us from seeing drought expansion from the south. Instead, our drought came from the north. But you can tell right now the drought's been getting better and better across the north and the west. Major improvement there. And that's because throughout the month of December, the places that were dry, that's what you're looking at here, were the central plains of the United States. Much wetter to the north, more snow there, and certainly in the western part of the United States. But boy, did December come in like a blowtorch. Do you remember this? It was just last month. I know it's been cold lately, but look at that. You get down here south I-72, all 4 of these major climate reporting districts in Illinois had their warmest Decembers going back to 1893. The Great Lakes, as of yesterday, were only 7% covered in ice. Sometimes they're over 60% covered by right now. And those Great Lakes, being so uncovered with ice, have some pretty epic lake effect snow on them right now. But I thought I'd give you those stats that just came out the other day. 127 years in NOAA's data set. Every state with the number 127 in it set a new all-time warmest December record. We were second place. I believe first place is 1933. That's the year that's in here. Now, why was that the case? Come back to where we started. These dumb troughs and ridges. All December long, a massive ridge of high pressure set over the Aleutian Islands. The jet stream dipped into the west and ran over a big ridge that some days set over Memphis and some days set over Atlanta and some days set over Bermuda. But it was always somewhere in here. And that ridge is what kept us away from getting all this cold air up here in Canada. How cold was it? Most daily high temperatures in Canada for the month of December were between -20 and -30 Celsius. It was extremely cold up there. And so we ask ourselves, we need to predict this, right? How do we figure out where this is going? What's the next steps? And every year I find that on February 2nd, more people trust that stupid animal than they trust me. And I don't understand it. And I joke, but I have several more degrees from that university than this particular critter does, who probably doesn't even know it has a shadow. This is just for fun. Are we all clear on that? We yank this thing out. It should be sleeping, right? It's a hibernating animal, and ask its opinion of its shadow, which I'm sure it doesn't even know it has. In fact, if it sees it, it's probably terrified. Let's rely a bit more on some deeper science. Now, at the beginning, I thought I'd tell you a funny story about Aristotle. This is the one I want you to remember. Please listen, and then we'll finish this all up today. That is Edward Lorenz. He is the father of chaos theory. Do you remember the movie Jurassic Park, where Jeff Goldblum is hitting on, I forget her name, the woman in the main female character? He's dripping the water on her fingers and telling her how it's going different directions, and all that's because of chaos. He ripped that off of that guy, who was probably not as successful with the ladies, given the overall look here. But I'm going to tell you something he did in the 1940s. Now, this was long before we had a weather forecast model to tell you what the weather was going to be. He comes out and says, listen, because of chaos, with perfect technology, we'll never be able to forecast the weather accurately. That's within 3% error. We'll never be able to forecast accurately beyond 21 days. He said that in 1940. You want to know where we are? Are you ready for this? We're getting close. Actually, that's a huge lie. Right now, our 3-day accuracy is within 3%. We're 98% accurate. 5-day, we're currently at 92%. 7-day is sitting at about 80%. And the 10-day forecast, can you all see it, is right now at 50-50. Now, this is telling you exactly what's going to happen on your farm, because I'm about to give you a 7-month forecast. But it's not predicting what's going to happen right on your farm. It's a different style of forecasting. But if you wouldn't mind, can I tell you why this guy knew what the heck he was talking about? Watch this. Remember this event back in mid-October? Massive blizzard in the west? It came through and dumped a bunch of snow on Montana, hit Idaho pretty hard. That snow was 18 inches deep across those states in mid-October. Severe weather outbreak to the south, big squall line producing hail straight line winds that went through parts of Kansas, ripping through the wheat there. And then we saw this on the backside, a big tornado. Why I'm bringing this up is, this is the storm system that ruined your October. That was the week of precipitation from that one system. 2.5 inches of rain in this particular area, and we couldn't get back in the fields for about 9 days. Now watch. When did we know that that massive winter storm was going to be there? Are you ready for this? Edward, like I'm on a first name basis. Okay, Dr. Lorenz would have been really impressed with this. Are you ready? That was the trough in the jet stream that produced that winter storm. And as I click play, that arrow is going to show you where that trough was every day before it was a big plains blizzard. So at one point it was in the Gulf of Alaska, then in the Bering Sea, and then in the North Pacific as a tiny little wiggle in the flow of the atmosphere. 13 days before it was a blizzard for the northern plains, it was that little insignificant feature there. You want to know what it was before that? It was a typhoon west of Japan, right there. And 2 days before that, that typhoon was north and east of the Philippine Islands. And 2 days before that, it was a typhoon right there gathering strength. And you go back to the 24th, which it was right there getting going, and then the 22nd, that was our high plains blizzard. There's not a soul on the face of the earth that was looking at this map on that day going, oh, geez, this is going to be a huge blizzard. We got to get ready for this. We didn't even know this was going to become a typhoon, for crying out loud, let alone get into the Bering Sea, cut across the Aleutian Islands, get into the Gulf of Alaska, jump over the mountains, intensify, and chase you out of the fields for 9 days. You see, the farthest back we can trace a weather event is 21 days. So you better believe we can't forecast it perfectly more than that. This is not easy, but let's talk about it now that we've got that far, and we'll finish this up. That La Nina is peaked out. See the cold ocean water right there in the Central Pacific? This is going through October now into November. Getting into December, it reached a peak in December. Look at the extent of that cold water. And that La Nina set everything up that we've been discussing today. And that particular La Nina, we've been studying it for a while. Guess what it is? A pressure shift. That's all it is. And the pressure shift's making those trade winds strong. Over 7,000 miles of open ocean. And the atmosphere says, well, if you're going to send wind this way in this direction, I'm going to have to change what it's doing north of that in this direction, which is where we live in the westerlies. We've been studying it for 70 years trying to figure out what it's going to do. This is what it typically gives us. A jet stream pattern that makes it really cold in Canada. The flow comes right in between the warm and the cold colors, and we get stuck in the middle. The rest of our winter is going to be dominated by that one thing. Now, back to make my points and stitch them all together. The National Weather Service, because of 7 years' worth of research, says you all better get prepared to have a wet rest of winter, risk of ice and snow, because it's coming. But when you get over here to the southern plains, this area, drought expands and persists for the rest of winter. That has me extremely concerned, because I have to go to Texas next week, and I have to tell them this, and they're not going to be happy about it. The cotton industry is really worried about the drought expansion here. The National Weather Service says this whole region is expected to see drier than normal conditions for the next 3 months. We're in this area, we're expected to see above average. Why? Because of that La Nina. These are brand new data, just came out. You can see here that the long-range forecast, February, March, and April, doesn't matter if the models are coming from the United States or if they're coming from Europe, they've got the Mid-South through the Ohio Valley active. Drought continuing to develop in the plains. It's in both models. This is the major concern going forward. Right now, from today through the end of February, that area is expected to take back over with a very active storm track. And we're watching it carefully for 2 types of systems named after some guy named Miller, a Miller A and a Miller B. We're about to get our first good Miller B storm. Unfortunately, if you're from this area, it's going to go too far to our south. Are you ready for this sucker? Here's what that snowfall looks like from the latest run from the European model. Look at it add up here. Ready? The blues start at 4 inches. And if you'd like to see something funny, go to Atlanta when they have snow or ice. You'd think it was the end of the world. It snowed like that in Atlanta about 10 years ago.
It ain't funny. It ain't funny.
Yeah, they made snowballs from the snow about 10 years ago, the last time it snowed in Atlanta like this. And they all tried to burn the snowballs because they thought it was a government conspiracy. They just don't get it down there. But we're missing out on this, and we've been missing out on snow for a while. You know, right here in Champaign County, we have measured less than a ½ inch of snow so far this year. And my kids could not be more mad at their dad showing them maps like this where we're in about an 8-inch snowfall deficit so far right now. Because currently, we're sitting at 0.1% of normal. And this is all going to get missed again. I'm sorry, there's nothing I can do about it. But you know what? The cold air that's coming in on that bare soil, like we just saw those deep freezes, is busting it apart. And that is a very good thing. The snow will insulate it. Let's get on from there and talk about temperatures. We're mild right now, but behind that, some cold air is coming in this weekend. But if you're worried about energy prices, take a look at this. This is day 5 through 10, and we'll do this quickly. This is day 10 through 15. We got some really cold air that's settling back in around the Hudson Bay. So enjoy this. This is shorts and t-shirts weather compared to what you're about to get once we get past the middle of this month. The cold air is going to be returning in a big way. Questions everybody asked me. We're going to have another outbreak of cold air like we had last year in February. Oh, by the way, you want to know proof? You want to know proof that nobody's out there forecasting these big high-end events 6 months in advance? Nobody became a billionaire off of this one. This was what water towers in Texas looked like last year when burst pipes happened in mid-February. When did I know about it? About 15 days before it occurred. I was like, holy cow, we might get 30 degrees below normal. That's what it ended up doing. Is something like that going to happen this upcoming go-around? Well, not when the polar vortex looks like that. Polar vortex has been very well behaved this year, just sitting and spinning over Greenland and over the Arctic. Until that sucker gets squeezed and stretched and split apart, the joining up of the troposphere and stratosphere to give you brutally cold air is not in the works. So we're going cold, but not as cold as it could be if that thing were going to get disrupted. So Jeff, this is where I'm going to stop here, all right? We're going to talk about this La Nina, what it's doing. Because take a look at this. You ready? Now, I put this at the end so you'd remember, but I forgot that your stomachs are getting rumbly right now. So tune me in. Listen. La Nina has peaked. And over the next 6 months, nearly every forecasting system out there projects it to go back to neutral or even warmer than average. That's El Nino territory. And if it continues to do that, where these waters warm up, there will be a battle between this warming, where we have our La Nina transitioning to El Nino, and that cold water right there. Now, if you've ever heard me speak, I will tell you that in summer, if there's extensive cold water that goes from the Gulf of Alaska off of the Baja here, in other words, if this gets colder than it's currently being forecast, that is terrible news for the Midwest. Because that means the West is cool and rainy, which puts us under the ridge where it's hot and dry. So thinking about that, this is the greatest bit of source of risk as we go into next summer. Everybody in this room, we need all of this warm water to fill that in. If that occurs, 60% of the time that this is all warm, we have above trend yields. Remember that. So I'm watching this carefully. In the meantime, though, this is what the latest forecast is. Remember me harping on the drought in the southern plains? The models for April, May, and June, look at the browns and reds. The US models are here. The European model is here. You can see that they're taking that dryness and bringing it back into the plains in both situations. At this point, every long-range model that's out there has given you great spring precipitation. This is not the same setup that drives you out of the fields like we saw in 2019. This is just above average early season precip. And you know with the topsoil that we have, that pulling in that moisture in June can help you survive a long stretch of drier weather should it show up in July. But right now, this is all roses for us. This is a great scenario, not west of us. And for our friends down south, the drought that's been in southern Brazil from, I'll rip out the states here for you, southern Mato Grosso do Sul on the Paraná River, which is here. Paraná, this is Santa Catarina, and this right here is Rio Grande do Sul. These areas have been in record drought, and at the same time, right here between, this is Tocantins and Bahia, some places here have had a 20-inch surplus of precipitation, on top of the fact that they normally get 3 inches of rain a week anyway. So it's been extremely wet north into Mato Grosso. And by the way, if you're unaware how big Mato Grosso is, you can put 5 Iowas and a Tennessee inside of that. This area right now has been extremely wet, and they're going to go over dry, while some rains try to work their way south. Looking at their root zone soil moisture, is this problem going to go away? No chance. 2 to 5% soil moisture for much of Argentina, Paraguay, Uruguay, and southern Brazil right now. The little bit of rain that's coming into this area, right in through there, is not going to correct the longer-term drought. But listen carefully. The map on the left is precipitation anomalies for the next 10 days, so drier than normal or wetter than normal. This is a great forecast north if it doesn't last. What I mean by that is they're trying to get a first crop of soybeans out here and put a second crop or safrinha crop, a corn in up here, Mato Grosso being the biggest state that does that. Drier weather now is going to let them do that. But if you notice, where is the rain down south? It's in southern Rio Grande do Sul. This is not a big crop area right here. It's in Uruguay, which is right there. It's along the Paraná River, but not over toward Cordoba. Cordoba is the Champaign County of Argentina. And they're not getting the excessive rains that they're getting to the north. So this little bit of rain right here is not corrective on the longer term problems with South America. And I'll be honest, I told Matt this at the beginning. I don't really care if it goes drier here right now. What I care about is the fact that La Niñas, when they fade through April and May, tend to give this area a much earlier stop to the monsoon. And the monsoon typically shuts off at the end of April. But they don't harvest the corn there until late May and June, which means their grain fill time period could get affected by this. Long story short, in my report every day, I put something about the changes in South America. I produce videos twice a week about it because this situation is fluid, just like what Matt said when he was talking about the markets. That is probably the biggest story that we've got going on right now.